My dear viewers, welcome today. I'm Mr. Michael Samuel, and today I want to show you on how to draw trigonometric curves, that is sine curve, cosine curve, and tangent curve, ranging from 0 degrees all the way to 360 degrees. So this is a sine curve. We'll know today by the end of this particular tutorial on how to be able to draw sine curve. That's a wave. Then from there you'll be able to draw a cosine curve also. And then finally you'll be able to draw a tangent curve. So let us begin with this question. So we have a question here in which says draw a graph of y is equals sine x for 0 degrees is less than or equals to x is less than or equals to 360 degrees, and we have to use an interval of 30 degrees. So for this kind of a question, we need to come up with a table for the corresponding values of x and corresponding values of y. So we make a table. So we are going to have values for angles. That's the row for angles. So here we have x, and then y is equal sine x. So this is what we needed to find. So in our case here, x is 0, then 30, intervals of 30, then 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and finally 360 degrees. Then from there we need to fill when x is 0, sine 0 will be 0. When x is 30, sine 30 will be 0.5. When x is 60, sine 60 will be 0.8660 for significant figure. When x is 90, sine 90 will be 1. When x is 120 degrees, so sine 120 will be 0.8660. When x is 150, we have y sine 150 will be 0.5. When x is 180, sine 180 will be 0. When x is 210, sine 210 will be negative 0.5. When x is 240, sine 240 will be negative 0.8660. When x is 270, y will be minus 1. When x is 300, y will be negative 0.8660. When x is 330, sine 330 will be negative 0.5. And finally, when x is 360, sine 360 will be 0. Fine. Now we have this table for the corresponding values of x and y. Therefore, we are going to plot these points on the Cartesian plane. So we move on, and here we have now the Cartesian plane. So we are going to draw the x-axis and the y-axis, and bearing in mind the minimum value of x and also the minimum value of y. So in our case here, in this table, the minimum value of x is 0, maximum value of x is 360. And for also y, minimum value is minus 1, maximum value is 1. So that's very important when we draw the graph. So let us now draw the x-axis. So we have the x-axis, and then we have the y-axis, and from there we put intervals of 2 big squares in each of the case, such that the interval will be 30 degrees for x-axis and y-axis to big square to represent 0.5. So from there, now we should be able to start from 0, then 30, then 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and finally 360. In the same case we do with the y-axis, the negative value we have minus 0.5 and minus 1.0. Positive axis we have 0.5 and 1.0. So from there we use the table that we did run. Now we are tabulated so that we plot all the points, and here is the table. So we have the table for the y is equal sine x. So when x is 0, y is 0. When x is 30, y is 0.5. So at this particular point. So when x is 60, y is 0. So to 2 decimal places, that will be 0.87. And here one small square is 0.05. So this will be at this particular point. Then when it is 90, y is 1 at that point. Then 120, 0.87, that point. When x is 150, 0.5, y is 0.5. When x is 180, y is 0 at that point. Then when x is 210, y is minus 0.5 at this point. Then when x is 240, y is negative 0.87 to 2 decimal places, and this point is here. Fine. When it is 270, y will be minus 1, that's the minimum value. Then when it is 300, minus 0.87 at this particular point here. Then when x is 330, so we have minus 0.5 as the y coordinate, so at that point. And finally 360, y is 0. So that's what we have. Now we can be able to plot a very smooth curve from 0 through all the plotted points correctly. So if we plot it, we draw a smooth curve from this point, that's what it shall be. So now this is a sine curve, and we label it as y is equals sine x. So that's how we draw a sine curve. Then we move on, and now we draw a graph of cosine x. So here we have another question. Draw a graph of y is equals cosine x for this range of values from 0 to 360 degrees, and again we are going to use an interval of 30 degrees. The same way we come up with a table of values, and that is we have x and then y is equals cosine x. Then from there we put all the values from 0 all the way to 360 degrees all the way. So we fill the table, and then we get the corresponding values of x, which is cosine x. When x is 0, cosine 0 will be 1. When x is 30, cosine 30 will be 0.8660. When x is 60, cosine 60 will be 0.5. When x is 90, cosine 90 will be 0. When x is 120, cosine 120 will be negative 0.5. When x is 150, cosine 150 will be negative 0.8660. When x is 180, cosine 180 will be minus 1. When x is 210, cosine 210 will be negative 0.8660. When x is 240, cosine 240 will be negative 0.5. When x is 270, cosine 270 will be 0. When x is 300, cosine 300 will be 0.5. When x is 330, cosine 330 will be 0.8660. When x is 360, cosine 360 will be 1. Fine. You already have these table values. Now we need to plot these points on a graph. So here now we have the graph already. I'm still using the same scale, so it's a matter of drawing when x is 0, y is 1, so that particular point. We plot the point. When x is 30, y is 0.87 to 2 decimal places at that particular point. When x is 60, y is 0.5 that point. When x is 90, y is 0, this point here. When x is 120, y is minus 0.5 at that particular point. When x is 150, y is negative 0.87, at this particular point here. Put a mark. When x is 180, y is minus 1. This is the minus 1, that particular point. When x is 210, y is negative 0.87 to 2 decimal places, that point. When x is 240, y is minus 0.5, that is the point. Then when x is 270, y is 0. When x is 330, y is 0.5, this is the point. Then when x is 330, y is 1. Y is 0.87, this is the point here. When x is 360, y is 1, so this is the point. Again, we have plotted all the points correctly. You can see it is following a curve motion, and in this case we are also going to actually draw the curve. This actually graph of y is equals cosine x, so let us draw the smooth curve from this point, and this is what we shall be able to get, going all the way through up to this point. So that is a curve, cosine curve. At the y-axis it cuts the graph at 1. Fine. Finally we get to the graph of tangent curve or tangent graph. So for tangent graph, so this is what we have. Also we are going to draw y is equals tan x for this range of angles from 0 to 360. We shall still use the same interval of 30 degrees. So we come up with a table. So we have a table. So here we have the value of x, and here y is equals tan x. Then from 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, and 360. Then we substitute the values of x into tan x, where we have tan x 0 is, tan 0 will be 0, tan 30 will be 0.5774, tan 60 will be 1.732, tan 90, this is undefined. If you use your calculator, you'll find that it is writing math error. This is undefined, and at this particular point we have asymptote line. So we shall see that once we plot the graph. Then we have tan 120, this is negative 1.732, tangent 150, that is negative 0.5774. Then tangent 180 is 0. Tan 10 we have 0.5774. Then tan 240 we have 1.732. Then tan 270 we have this undefined or infinite. Then tan 300 we have negative 1.732, and then tan 330 we have negative 0.5774, and finally tan 360 we have it as 0. So we are going to use this table to also plot the graph of y is equals tan x. So let us move on, and we draw it on the graph. Now this is what we have. Maximum value here we have 1.7, so we can take it up to 2.0, fine, and the minimum value can take up to negative 2, though it can proceed onwards. Now we start with the first one. So when x is 0, y is 0, we put the mark. Then when x is 30, y is 0.58. So in our case, here on the y-axis, one small square represents 0. That is 0.1. So allow me just to approximate this to 1 decimal point. That will be 0.6, and it will be at this particular point. Then when x is 60, y is 1.7. 1.7 is at this particular point. I put a mark. When x is 90, y is undefined, so the curve will never reach 90, though it will get closer. So at 90 we have asymptote line, so we are going to have an asymptote line. So I will draw a dotted line. So this represents asymptote line. Then when x is 120, y is negative 1.7. So that is in the negative direction. It will be at this particular point, and you put the mark. When x is 150, y is 0.6, that is to 1 decimal point. So it shall be at this particular point here. Put a mark. And then when x is 180, y is 0 at this particular point. Put a mark. Then when x is 210, we have 0.6 to 1 decimal point, and it will be at this particular point. We put a mark on it. Then we move on. When x is 240, we have 1.7. 1.7 will be at this particular point here. So we put a mark on it. Then when x is 270, again y is undefined, so at this particular point again we are going to have an asymptote line, so we draw an asymptote line. Then when x is 300, y is negative 1.7. Negative 1.7, so it's at this particular point here. Fine. Then 330, y will be 0.621 decimal point. So at this particular point here, we have put the mark. Then finally, when x is 360, y is 0. So at this particular point. Fine. Now this is what now we have, and we need now to draw the curve, smooth curve. But remember, it will never touch the lines at 90 and also at 270, since they are undefined or asymptote lines. So we start with the first one, and in our case we shall have, so this actually graph of y is equals to an x. So at this particular point, now we can draw the graph, and this is how it will appear like. So that's how it will appear for this part. Then the next part will be, that's how the curve will look like. At this point, it will get closer to this line, but it will never touch it. The other part here also we draw, and that's how it will look like. So that is it, and that's how we draw trigonometric curves, that is for sine, cosine, and tangent curve. If you have any question concerning trigonometric curve, don't hesitate to share on my link. I'll be able to review it, and perhaps I'll be able to answer you as required. Thank you so much for your patience and for your time to watch this mathematics video. See you in the next lesson. Thank you so much.